Okay, welcome back. So in the last video we talked about what happens to how we can calculate the velocity of an object when the mass of the objects are given. We can calculate the acceleration of the object, and when the distance is given, we can put linear equation of motion, and then we can calculate the velocity of the object. So that was the last video. So in this video I will be talking about a new concept in which two masses are kept together in a single side, balanced by another mass. So balanced by means actually there is an acceleration, but it will be something like this. So what happens if an object is placed like this? I put here 8g, and here a mass of 3g and a mass of 7g. Now what happens if a system is placed like this? Now you know what happens when a mass of like m1 here and m2 here and supported by a string here. What happens now? Now what happens if two masses are kept on same side, balanced by this one? Now, balanced by is the total weight on this side is not equal to this one, but two masses are on one side and only one mass is on the other side. Now you know from the previous videos. So if you have not watched those videos, I invite you to watch those and come back here. So those are necessary to find the solution of the acceleration and the tensions. So the previous videos what we did was, there was a mass here, there was another mass here, and then we found the common tension and the common acceleration, and we found the velocity in the last video. So in this video, what happens when another mass is connected to this mass, when another mass is connected by a string to this mass? So it will be the same, but we have to carefully mark the external free body diagram, the external forces. The only thing is that now since this is the same string, right? This is the same string, right? So the tension at this point will be equal to tension at this point will be equal to the tension throughout the string will be equal. Tension throughout the string will be equal, so the tension experienced, the upward tension experienced by this object will be equal to the upward tension experienced by this object, because the pulley is not rotating. So this is T1, I will take T1 because there are two strings. I will take now T1 and T2. So this is one T1 and this is T1. So this string is another string. So we cannot actually say that the actual tension of the string is T1, so we will take the tension of the string to be something like T2. As I mentioned, that's why I mentioned in the first video, if this is T2, the tension experienced by this object is T2 downwards. See. Alright, so if you consider this object, you can draw the forces here. 8 kilogram object, there's T1 in this side, 8g this side. For the 3 kilogram mass, there's T1 this side and 3g mass this side. This T2 force is also experienced by this object. T2 force is also experienced by this object because this is connected to this. So this will be 3g plus T2. And for the 7 kilogram object, there will be T2 here. Right? So there will be T2 here, and there will be 7g weight acting downwards. So here the 7g weight will be acting downwards, and 3g weight will be also acting downwards. So the total weight experienced by this object is 10g. Right? 10g. So you can put F equals ma individually to these objects. F equals ma. Assuming that the total mass is on this concentrated on this side, the total mass is 10 kilograms, and the total mass on this side is 8 kilograms. So the possible acceleration will be downwards from here and upwards from here, and not there. Yeah, upwards from here. So by putting F equals ma, I want to make a positive. So for this object, acceleration is this way. For these two objects, acceleration will be downwards. It will be downwards, right? This is upwards. This is downwards, and this object also downwards. So for this object, the acceleration is upwards, right? So I will put F equals ma upwards so that the acceleration is positive. So T1 minus 8g is equal to 8 times A, equation number 1. T1 minus 8g is equal to 8 times A. And for this object, the acceleration is downwards, so I will put F equals ma downwards. F equals ma downwards. So the total force acting downwards is 3g plus 2t. Sorry, T2. And this T1 is negative because it is acting upwards. This is equal to mass of this object times A. This is equation number 2. Right? This is equation number 2. 3g minus T2 minus T1 is equal to 3a. And for this object, 7 kilogram object, acceleration is again downwards, so I will put F equals ma downwards again. So the force downwards is 10g, and the force upwards is T2, and the mass is 10, and the acceleration is v. So this is equation 2. Now these are somewhat complicated. I will write the equations on this side, but that will be very visible to you. So first equation is T1 minus 8g is equal to 8a. Equation number 1. T1 minus 8g is equal to 8a. Second equation is 3g minus T1 plus T2 is equal to 3a. Equation number 2. And minus T2, 10g here, 10g here minus T2 is equal to 10, sorry, this is 7 here, right? This is 7 here because the total mass is 7 and total force is 7. So this is 7 here. Like this. So these are the three equations that you get from this system. If you add up all these three equations, T1 to plus T1 to minus T1, it will cancel. Right? This is plus T1 and this is minus T1. Plus T1 and minus T1. Plus T2 to minus T2 cancel. So acceleration will isolate. Here will be g. So g is given in this sum. So you can find the acceleration. So I add up these all these downwards. Right? I add all these equations up. 1 plus 2 plus 3. So T1 to minus T1 cancel, T2 to minus T2 cancel. So here is 3g, right? Here is 3g, here is 10g, so that is 13g, minus 8g, that is 5g. Is equal to, here is 8a, here is 3a, this is 7a. So 8 plus 3 is 11, 11 plus 7 is 18, so this is 18a. So a is equal to, I see when g equals 10, 5 times 10 divided by 18, 50 divided by 18 is equal to 25 divided by 9. So this is 2, 9 and 7, so this will be equal to 2.7 approximately meters per square centimeter. 2.7 meters per square centimeter. So that's the acceleration. Now we have to find the values of T1 as well. From equation 1 I can write from 1 T1 minus 8g is equal to 8a. So a is equal to from 1 T1 minus 8g is equal to 8a. So we found a equal to 2.7. So here is T1 equals 8 times g is 10, 10 plus 2.7 is 12.7. So T1 is equal to 12.7 times 8 is 56.5. This is 16, 21, 2, and 101.6 newtons. So that is approximately equal to 102 newtons. So T2 from this equation 3, you can take from equation 3 from from 3 you can say 10G minus T2 is equal to 7A. So T2 is equal to 10G minus 7A. Right? T2 is equal to 10G minus 7A. So T2 is equal to 10G is 100 minus 7 times A is 2.7. So 100 minus 2.7 times 7 is 7 times 7, 49, 4 remains, so 14, 18, 18.9. So this is approximately 90, so this is approximately be 81 newtons. Right? So T acceleration is 2.7 square meters per square second. Acceleration is 2.7 meters per square second. T1 is 1.6 newtons, which is approximately equal to 102 newtons. T2 is approximately equal to 81 newtons. So in this video, I talked about another option in which two masses are concentrated to one side and only one mass is kept on the other side. So in the next video, I will be coming with a new concept. So thanks for watching this video, and I'll see you later.